Hi, I'm Heather Falcone, and welcome to Heat Treat Radio. This podcast is produced by Heat Treat Today and focuses on the real technical and operational decisions made in heat treating and thermal processing environments. Each episode covers practical knowledge, current challenges, and informed perspectives from people working directly in the industry. Today, we're asking a metallurgist, and we're talking about the ins and outs of process qualification and recipe development. And we're on site with the sponsor of our episode, ECM USA, in beautiful Pleasant Prairie, Wisconsin. It's a real treat to be able to record on site. We hardly ever get that chance. Joining me today is Vincent Lelong, Senior Synergy Center Manager and Metallurgist. Thanks for joining me today, Vincent.
Thank you, Heather.
So you have the luxury, since we are in your beautiful facility, you get to tell me not just about yourself, but you also get to tell me about ECM. So start off with your background because it is extensive.
I'm a metallurgist. I did college in France, and I started with ECM technology in 1999. And since then, I'm across the world, and mostly for 20 years in USA. So I do some presentation and mostly testing in the furnace behind us and in larger furnace.
Yes.
So I need to go on site, and it's our synergy center. So nice environment, clean, quiet today because we're filming.
That's right.
So hopefully we'll have a good time today.
Yep. And then tell me a little bit about what ECM does.
So ECM, we make installation of heat treatment. Mostly our main focus is on low pressure carburizing modular furnace, large installation and smaller. We integrate a lot of not just the heat treatment itself, but the pre-treatment like washing, storage, preparation of the load with robotic, heat treatment, temper, cryo, and everything. It's set up all together, and that is our main goal. It's integration of fully automatic installation.
A one-stop shop.
You
You go to one place, and we're going to make it all work.
And everything will be ready in a few hours later. Some days, sometime in function of the treatment.
Right.
But,
hopefully it all works.
No, it always works. It's a really repeatable modular furnace. So yeah, that is ECM. Then you have all the in USA we're focusing on vacuum carburizing, but we have also other type of installation for crystal growth, from silicon heat treatment, melting silicon for solar panel, and everything. So the ECM group, it's kind of very interesting about diversity of heat treatment and not just steel.
Right.
Can be other part. I'm specialized on the steel and very restricted heat treatment about vacuum carburizing, but it's maybe one day we can do everything else.
Steel makes the world run.
Yeah.
So.
And also with today with the modular furnace, after I've developed hardening, gas quench or quench, carburizing, gas quench or quench, now we do vacuum carbonitriding. We can do nitriding in the furnace. So you can have one installation for multitask heat treatment. So it's what the purpose of the modular furnace, the beauty of
more flexibility.
Yeah,
a lot more capabilities.
Yeah.
Well, that kind of brings us into like the first core question that we want to ask, because when you're evaluating bringing in another piece of equipment, or if you're trying to bring on a new process, it can be a little challenging. So
true.
What do you see are the biggest pitfalls, or what should we be, what do you see people struggling with most when it comes to process qualification, recipe development?
You like most of the customers say, I would like a good metallurgy, I would like a mechanical properties.
Right, make good parts. Number one.
Good.
Yeah.
But you need to look at what kind of installation you would like to do, use, the size, the type of part you like, and the process also.
Sure.
So in function of if you have a small part, do you want a bulk load? Do you want a special fixtures because the main target is distortion? Of course, everybody would like everything.
Distortion free.
Always, no problem. So, as a metallurgist, you need always to think not just at the heat treatment, because you ask me to heat treat, I will heat and quench in oil and say, you have the metallurgy,
It's done.
my job is done.
Right. It hit hardness.
Yes, exactly. Hardness, good. Vacuum carburizing, no oxidation, good. How about the distortion? Okay, let's speak about what can we do to reduce the strongness of the treatment itself. Let's do a gas quench, but let's work on fixtures also. So it's working with a supplier for fixtures, working with the customer, with the machining people.
Yes.
Sometimes, because we propose gas quench, people say, oh, gas quench, no distortion.
Right.
The first step is to get the metallurgy right. If you need 20 bar gas quench, you might have some distortion. Now, with experience, we know that the fixtures, it's also important. So we can work with the customer and supplier to propose the fixtures and test the fixtures to target the best cooling rate and everything. But we need to work with the machining people.
Sure.
If you have the machining people, they will say it's the fault of the metallurgist, the heat treatment, and the heat treatment will say no. Let's work together at the table. We sit, we do testing. At the Synergy Center, we have also a CMM, so we can measure before heat treatment, after heat treatment. I would say it's the most good feeling when you bring not just the metallurgists together, but the people make the part.
Yes.
We work together to have the best of the best.
Agreed.
So that it's a lot of work, but we have already years of experience, so we can maybe target a little faster than 20 years ago, for example. When you technology has changed, okay, you need also to work with steel manufacturing, the way it's made, and also the composition.
Right.
What I found with all the article we propose with customer work, if it's possible to improve your steel, you can reduce the quench pressure.
Sure.
If you need oil quench, already you know then distortion will be potentially, I say potentially higher. If you need 20 bar, it's one thing. Well, I did a presentation not so long time ago, and I found that distortion 20 bar in a nano or 10 bar in a nano were much better than in a larger load.
Okay.
So for one part, okay, maybe it's not true for one other part. Always, there are some words in treatment that depend. I don't like this
It always
word,
depends.
but it's true, unfortunately. So when you have work all that together, you can bring the best analysis. And I'm working before to sell a furnace, so I need to choose: is it better for the customer to have a smaller furnace, a larger installation? Really, that depends how many parts.
Right.
Diversity of part. If the customer have mostly small part, maybe the nano it's better. You have a faster answer because it's in and out. You don't need to buy so many fixtures. But if you have a larger part, larger furnace is better also.
Right.
So it's not one furnace better than the other. You need really to target what is your production.
Yes, right.
The same customer in facility number A, we may need a larger furnace, and the facility B, for one other type of part, might need a smaller furnace.
Yeah.
And that it's how we work together with the customer to target
Right.
what is important.
Yeah,
And I
pick the
think
right atmosphere, pick the right hot zone size, pick the right fixturing,
exactly.
raw material specs. All of
Yes.
those are going to influence how the
Yeah.
run's going to go. I bet you have some stories about TCE from fixturing and eutectic and inadvertent bonding.
Well,
And
I did few mistakes in testing to go to higher temperature because vacuum carburizing, we say we can go to higher temperature, but then I use CFC fixtures at the wrong temperature.
Yikes.
But today, the mixtures of fixtures can work, reduce the weight. To be a metallurgist and a heat treater, technically, I prefer to heat treat part than heat treat fixtures.
I agree.
When I see some customer running load with almost more fixtures and part, I'm saying, what do you heat treat?
Right.
Do you lose money on fixtures and heat treat every day fixtures than more than part? So
such a big weight differential between fixturing and the parts.
Sure.
How much lag time on your heat up and cool down are you wasting on having too much fixturing?
It's true.
Well, it's kind of interesting to talk about that because once you're in the recipe development, how do you balance technical requirements, the repeatability, and the production kind of realities?
So repeatability is to you design the load. Then you have your, you know the quantity of part. You know the surface of your load. Not necessary, I will say. Most of the time we don't know, and it's heat treatment, so some.
It's still a black box. It's an art, what we do.
Yeah, pretty much, yeah. Technically, it's a good thing because we put something inside the furnace, it's coming back. We don't see much difference, but the mechanical properties are completely different. So it's kind of magic.
It is.
So you define your load, you define your heating time to be at temperature. And when you're sure you're at temperature, you start to carburize. I will speak about vacuum carburizing. And first, we have a software for the carburizing boost and diffusion. So you put some few parameters and you have a recipe, generic. Or if you like go in detail, you can improve it. But directly the software will give you some things and mostly will work.
Technology is so cool.
Yeah, it's getting better and better. So you define then say the type of furnace. Of course, when you have one part, is not the same than when you have 3,000 parts.
Right.
The density of the load will influence your gas flow. And the capacity of your installation.
Right.
Okay. Most of our large installation have a maximum of acetylene of 4,000 liters.
Okay.
But you can play with the gas and the duration of the boost and diffusion to go inside the part. When you have a blind hole or you need 3 millimeters, you carburize. Acetylene is beautiful molecules and go everywhere. Sometimes where we don't want that.
Right.
But it's why you have stop off. Stuff like that. So you define your load, you define your recipe, your flow of gas, you run a test, you analyze the metallurgy, it's good, usually it's done. You don't move from that.
That's what production wants to hear.
Yes. No, when you are a heat treater, today you receive 10 parts, you need to heat treat them.
Right.
Tomorrow you will receive 20 parts, and maybe you need to run the same recipe. So mostly you can run the same recipe for 10 parts and 20 parts. Use the parameters of the larger load for the smaller, if possible. The result will be mostly the same. But no, the cost will not be the same. So it's where you can optimize your recipe for a different type of load. You know, half of the load, a full load, you change the flow of gas, you reduce your heating time, because why you will 2 hours when in 1 hour is at temperature.
Right.
1 hour, it's money. So
Yeah, you got to turn and burn.
and it's where you define your database and your repeatability. In the past, as a failure, I had some customer had create a recipe for, I will say, a specific quantity of part and a design of load. A few years later, customer will call and say, doesn't work. So now we record everything with computer today. So you have a database, you have the curves, very important, and you can go back and say what was wrong.
Right. What changed?
And in this case, the customer was running the double quantity of part in the same load without changing anything of the recipe.
Makes sense. Start there.
Heating time was not long enough. Gas flow was not long enough. And I found that they were not working at the right pressure in the furnace. So failure. I said, change that. No news, good news, usually. It's if the customer doesn't call you, it's because everything works. So it's the beauty of this furnace. It's So the repeatability, it's like that. You need to always look at the curves. And today, if you have an issue of temperature out of the range, you will have alarm. So constantly you can check if it's good or not without checking the metallurgy. If you treat a big part, usually you don't cut the part. Because if you have 6 parts in a load or 10, no, you have samples. So you had to validate primarily your sample and your real part at the beginning.
Make sure it's representative.
Exactly. Or if there are a difference because you cannot find exactly the same material, you know the difference. And the difference would be always the same.
Right. Make it predictable.
Yes. And go there and we have some customers, they will maybe check one load per day or per shift and not every load. Like I said, if you have 3,000 parts in a load, you can check a part.
Right.
When you have 6 parts, you will not cut a part.
No.
Unless you really want. But usually you do not. You have sampling. Or if the installation tell you all good, why you will check. It's so it's where you check repeatability. I will say you still need a lab.
Yeah.
To not check the metallurgy, it's sometimes difficult. I will say you should always check again. Repeatability or aleatory, a statistic saying, hey, today we take a part and we check. Is it good? Continue. So
that's kind of the target of qualification, right? To get those parameters predefined and then
in time you need to be sure nothing changed.
Right. So are you requalifying? What does that process look like?
Yeah, to be sure that nothing changed, material wise. Sometimes I have funny things, and you run the same material and you achieve 35 HRC, and at one point of time you get only 25 HRC, and the same material on the paper, but something happened. So you need to go back in time and figure out what was origin. Is it the heat treatment, is the installation, or something wrong?
Right. Use all the data that's available to you.
I will say that is where you check the productivity.
How about the quench media?
So the quench media, when you develop a recipe, if you do a quench, you will always do austenitizing. Classic, you don't want a crack, and you will do your carburizing, austenitizing, and go to oil quench. So it's pretty easy to switch from atmosphere oil quench and vacuum oil quench, because technically the recipe is pretty much the same.
And we're going to cover that ground extensively, because I know it's kind of scary to even consider that possibility.
Now, when you go with gas quench, if you don't know what to achieve or you're not sure, you put 20 bar.
Sure, 20 bar. Like,
Yeah.
that's the easiest in the world.
Exactly. 20 bar, and you get what you get. The advantage of the gas quench, a lot of customers will say, okay, do I need to do a direct quench? Do I need to do a sanitizing? Most of the time, we'll say direct quench.
Okay.
And we found that you don't crack with gas quench. Whatever the pressure, we never have really much a crack, or a customer say, oh, the part break due to the gas quench. Never happened.
Wow.
There was a question of the competition, and I said, did you ever see a crack with gas quench? No, because it's the way the gas quench and cool down the part, then it's less strong than the liquid, so you don't have this potential issue. Now, like I said, if you don't know, you stay at 20 bar. If you like to optimize, you can reduce. But in the same time, you can reduce, but you need the metallurgy.
Right, you've got to get your core hardness, you've got to get...
Exactly. Yeah. So your limit, it's when your metallurgy is not right. So you reduce the cost. Also, if you reduce the pressure and the speed, you will reduce the distortion, potentially. Okay?
Always a good thing.
Yes. If you have a shaft, don't put it horizontal, because whatever you quench, it will not be straight. Okay.
We've potato chipped a few parts over the years. Yes.
Me too. I try horizontal in some case. Interesting. You need more support. I think it's possible, but nobody want to try.
Why?
Because
why bother?
Vertical, it's easier.
Yeah. And if you're qualifying, just make the fixture that's going to support it. Don't mess with it.
Change.
Yes.
Okay?
Yes.
It's always a big question. It's we do this way. Now for gears, in each treater, I see a lot of vertical position for gear on the road. As operator, I don't like that.
Oh, tell me more.
But because it's heavy.
Sure.
We have already a difficulty to find operator in a treatment.
That is a thing, yes.
So
yes.
If it's heavy, nobody want to do it. For a robot point of view, it's more difficult. So most of vacuum carburizing and gas quench gears are heat treat horizontally on fixtures, and most of the time with offset position, and that shows, and it's what will give you the best metallurgy, but also the less distortion.
Right.
So it's a way to think. Vertically, for machining people, it's very difficult to remachine something oval. So when you put horizontally, yeah, you can do potato chips, but machining people have learned to grind and to reshape very easily the part, if it's possible.
Right. If you're already near net, you know, it's going to be a different story.
Exactly. So there it's where you check your distortion and repeatability of process. It's the fixtures. Okay.
And I would think working with the customer as much as you can to see if material can be left on the part, if we do need to have grinding, if we do need to have repair or recovery for any possible distortion.
It's the funny thing is, let's say you take the 6-speed. 6-speed, everybody went to vacuum carburizing gas quench. Great. Objective, zero distortion. You heat treat, you assemble.
Yes. In theory.
No, in truth.
Really?
Yes.
Okay.
That was a target.
Okay. Ambitious. I like it.
Yes, but that was, you know, when you have a new product, you can go to new technology, you can work on the fixtures, you can work on everything. So we work a lot with the car manufacturer to do the best heat treatment, the best fixtures, the maximum of part, of course,
Yeah.
and repeatability. And these furnaces are running part, like a million of part.
Wow.
Yeah, it's crazy.
I mean, yeah.
And so is why we know vacuum carburizing works. And it's repeatable. So this high volume, we had to work on zero distortion. The funny things, the specification then didn't change, metallurgically speaking. So I will say that was most of the time was 0.3 to 0.7 millimeter. It's a pretty large gap. So no problem. Then we went to the 10 speed for most of the automotive. And then the distortion was the target because of the return of experience of the 6 speed, the noise. People don't want a noise. Today, we go to, with the 10 speed, we start to grind a lot. 0.1 millimeter. Yeah,
That's
so
a
you have
lot.
to compensate your carburizing process longer and deeper, but also most of the customer reduce the metallurgical requirement.
Okay.
So more sharp. I mean, from 0.3 to 0.7, you went to 0.5 plus or minus 0.05.
Okay.
Much shorter. And today, with electrical application, so you like zero noise, of course, because you are here, everything. You have a lot of grinding. And when I say a lot, it can be like 0.2 millimeter.
That is a lot of post-process work.
You have a perfect teeth. You need to anticipate longer carburizing. And it's great. And also what I see at Metallurgist, it's no, you don't have a general metallurgical specification, but each area of a part, we have this own metallurgy. I mean, you have the pitch of the gear, classic, the roots, classic, a minimum. But the tip, sometimes no, you have a specification of the tip.
Sure. Yeah.
So customer said, I don't want more than 0.8.
Just for that area.
Yes. And then you have, let's say, I think the part get more and more complex, and they have more than just one application or function, should I say. So you have a spline, you have a double teeth, you have, and each one have its own requirement. With atmosphere furnace, to get that, doesn't work very well. With vacuum carburizing, you can achieve a very much a picky requirement. So that is a beauty, and it's a challenge always. It's to be good everywhere.
Well, to that point, what is that one of the things that stops people from considering the change from atmospheric to vacuum carburized, or is part complexity?
I will say the big company, they are not afraid because they know what they want, and they had already experience. I will say it's more the heat treater, the smaller company.
Sure.
To switch, it's very difficult with the requirement today. When you see the requirement on the drawing, it's funny because before there was heat treatment.
Right.
But
yeah, it's on this process sheet.
One line.
Done.
Surface harness.
Yes.
ECD, core
Right.
harness. Today you have, like I said, different requirements. And the funny thing, you have the requirement before it, after heat treatment, and final. So, and both.
Right.
So you know how much you need to take off. And not every area you take off. So you said keep more material. Sure. The advantage of that is more material, less distortion, but you will have to carburizing more.
Right.
So
ultimately may be more expensive for everybody.
Exactly. And then the machining behind the grinding costly also. So when we develop a recipe, we say to the customer, I say, try to, let's say you machine to the final dimension, and we do the treatment, and we see where we are for metallurgy and distortion. If we are not good, don't take off too much.
Right.
and then you adjust. And step by step, people know. One other story is a thread.
Oh God, threads. Yeah. The bane of every heat treater's existence, threads.
Yep. So I have a lot of questions about thread. Do I need to make them before a treatment? Do I need to put a mask,
Right.
paint, or
fixture, right? Mechanical.
or to not do them,
Right.
and do them after?
After. Ooh. Also expensive.
Also expensive, but I will say it's almost can be almost a robot application.
Oh, true. Yes, very good
Because
point.
it's what I will say. It's a way I would go.
Oh, how interesting. Okay.
To not do the thread before.
Lower risk.
First, you can, when you carburize, you can create a brittleness of your thread.
Right.
But also operator movement of the thread from crate to the fixtures.
Yeah, just bang.
Bing. You damage the thread. What do you do? Can you save the thread after a treatment? Not always. So then, part is garbage, and you add manufacture the part, heat treat the part. To put in the garbage is a cost.
Right, probably 80 or 90% of your whole cost.
Yep. So
gone in an instant.
My opinion, let's say you have a robot preparing the load. You have a robot take off and every time is the same movement. So then, thread or not, it's easier.
More predictable.
Yeah. So that is good.
Yeah.
But then the robot, if you don't do the thread, can put the shaft with usually the shaft with pinion on the thread on the end, put to a little induction machine, reheat, and then put in a crate and go back to machining, and
turn it.
It's off.
Done.
So there, I think it's my preference to not do the thread first. Now I have customers, they ask me for paint, they ask me for mask. Paint is not at, I will say, not at 100% safe, but you need specialists to put the paint. But there are some tricks as an heat treater know, and they do that for years, and they know their stuff. So
that's their secret. That's their.
It's I will say the heat treater have more secret about painting and protection of the part than the big company. They know better.
Their lives are on the line. That's all they do. So they have to make it perfect.
True. Yeah, exactly.
Yeah.
So it's you can learn a lot from heat treatment people. It's they know.
That's what I always recommend to the captives. Get out to as many heat treat shops as you can see, because it's going to make your in-house heat treat better.
Yeah. Understand what experience and years of experience did. It's all tricks. Heat treatment is tricks after tricks. So it's like it could be where the potential customer are afraid to go to heat treatment.
Yes.
It's
right.
How variety of information you need to catch to be good. It's
an interesting point that you brought up about being afraid, because vacuum carburize has kind of gotten that reputation over the year that it's difficult. It's tough to figure out.
Because we did a good job. we did a good job to say you can optimize. But in reality, if you have an understanding about what you like to treat, the carburizing process is made by a software.
If you're using ECM.
Oh, every other our software is the best.
I have to give you your chance.
Yeah. But every company has their own software. I will say ours is pretty simple and still scary for heat treater.
Yeah, process change is scary.
We have some, I will not say name, okay, but there are some companies, they make vacuum carburizing software where you need to know everything about the steel, the chemistry and everything. You need a carbon. We work with carbon. So put the carbon content originally, roughly, temperature you would like to heat treat, what you would like on the final. Software will give you something. And it will be good at 95%, will be good. Now, of course, you need to quench.
Yes.
Like I said, ball quench, no problem. Gas quench, 20 bar, no problem. Pretty easy. Straightforward, you get it. Optimization, it's where maybe it's more tricky. But it's like a atmosphere furnace. I work with atmosphere furnace, and every atmosphere furnace has their cheat sheet by
Right.
for the
Don't let the NADCAP auditor see. Just hide that.
true. But
Yeah.
you need carbon potential. You need your temperature, time,
Right.
and pretty much in vacuum carburizing is the same thing. It's temperature, your carbon potential, or what you expect for carbon,
Sure.
and the time, so the case depth you like achieve, and here is your process.
And then you don't need the cheat sheet.
Pretty much no.
It's gone.
No. Then
it's documented, repeatable.
yeah, it's and then you have to heat up and to quench. So strip heat treatment, it's heat up. To be sure you're at temperature, you carburize, and you quench.
One test.
Pretty much. I do a lot of one test. Customer asked me to run a test for a flex system, a larger system. I do it here first because it's cheaper for me, because it just
And
buy
you've
a
got the
slab.
stuff. Yeah.
It's here. I mixed a different part, different design, run. Oh, it's a 8620. Sure.
Let's go.
And usually it's good. Then I a nano load, it's like a 1/5 or one it's a one fixtures, and the bigger load, it's like 2 column of fixtures than you stack.
Right.
So there's not much difference. You study on a smaller scale, and you go to bigger, you just add little heat up, time,
and away you go.
and more gas, of course. And if you ask me what you need, put everything to the maximum. We're here to sell a spare part, so it's if you put everything to the maximum, you will be good. Maybe too good, and you might have more maintenance, but we'll provide a quota to do the maintenance.
Right. We'll give that to Allison. She'll take care of that for us. Yeah. As we wind up our recording here, it's important for us to cover, if there's one thing that you'd want our listeners to take away, rethinking about their approach to process qualification, recipe development, what do you want them to know?
So it's not difficult. You just it's like every treatment, you have to test it, and you will really quickly see that it's easy. But of course, ECM USA, we provide training, and we provide also testing. Then we can show you what is achievable, and to satisfy your question, or if you're a little scared, we'll show you how it's easy, how it's clean, there's no flame. If you have an oil quench, there's no flame also, because it's protection. Everything is protected. So it's not a difficulty. It's just one step. Not be afraid.
Take that first step.
Yep, exactly.
Explore the process.
And I think there are enough article, enough proof the last 25 years in USA, especially with the big automotive company and aerospace, and everybody go. So it's not a big deal. It's just but most of the people are, heat treatment or not, we don't like to change.
But they can partner with you, Vincent, who has decades of experience.
Yes.
Reach out to ECM,
True.
get in touch, start exploring.
Yeah.
Sounds good.
So it's and I would say it's what the funny things with decade of experience, what we were capable to treat 20 years ago, it's like not true anymore. We can do way better.
Absolutely.
The the technology is much stronger. Gas quenching is the gas quench are made to quench, not to cool. Okay, it's quenching. It's hard. It's almost as hard quench than oil quench. So all that you can do bulk load. Carburizing. I did not so long time ago carbo nitrating in bulk load. 20 years ago, you would have asked me to do that. I would say no way that works.
Right.
But today that works. So I would say it's it's just contact us and
start the conversation, right?
And I will be happy to show you. And I like my my job, and I like my.
You love your job.
It's
I'm gonna say it. You're very passionate, and
it's you know you don't do. I like testing because it's a challenge every day. It's
right.
Pushing the limit. It's like a movie. It's is it possible? Yes or no? If you follow the book or internet, they will say no, and I will say, let's try.
Right.
And I'm doing testing on some other materials than steel. Then, like I said, I would have not expected that works, and I show to customers, and yeah, we're going there.
Sure enough.
So modular furnace can be very versatile. It's I would say it's.
Well, it sounds like production's getting ready to fire back up. So.
Yeah.
They got to get things done. They've got tests to run and equipment to do.
We have a lot of testing going on, and it's. I cannot show you, but.
That's okay. If they work with you, they'll see.
Oh yeah.
Well, thanks so much, Vincent. It was great spending time with you.
Thank you.
This was a great conversation.
That was good.
Thanks for joining us today. I'm grateful to Vincent Lelong for joining us for the conversation. And thanks again to ECM USA for sponsoring our episode today. And you can find out more at ecm-usa.com or ecm-usa.com. If you'd like to reach any of our guests, or if you have topic ideas or are interested in sponsoring Heat Treat Radio, you can reach out to me at heather@heattreattoday.com. Heat Treat Radio is brought to you by Heat Treat Today. More technical content and industry coverage is available at heattreattoday.com. Be sure to like, follow, and subscribe, and make sure you leave us a 5-star review on your favorite platform. It helps others in the industry find the show, and it supports future episodes. I hope the audio is picking this up. This is awesome. This is my favorite part. Our mics are probably not getting all this, but they are getting things done around here.
I say that.
And this and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may not be reproduced in part or in whole without advance written permission from Heat Treat Today. Thank you for listening. I'm Heather Falcone.